Okay, having a look at a minimum spanning tree. So these are questions that might be worded to do with making sure each city or location is connected in some way to the network. These may be used for electricity cables, phone cables, water pipes, etc., where you don't have to travel from one point to the other in a certain you're not traveling there. They just have to all be connected in some way. So it differs from your shortest path type questions where you're going from a certain location to another certain location. These ones we just want everything connected in some way to the tree. So what we do when we do these type of questions, we first look for the shortest one in the whole picture, which we can see is that line connecting HF, which is 1. Sometimes you may be told where to start. If not, start from the smallest. So we've got our H and we've got our F are now connected. And we've got a 1 there. So when we're adding that up, we'll put the 1. Then you look at anything coming off H and F. So we've got the 12, we've got the 13, we've got a 2, we've got a 3, and we've got a 5. So we're looking for which one is smallest. So that's that 2 that we've got there, connecting our I now. So we've now got 1 plus 2. Now we want to look at each of those. So we've got our F, we can go the 12 or the 5. Our H, we've got the 13 and the 3. The I has, that's an 8 there. 4, 6, 11, or 4. So out of those options, that 3 is the smallest one. So we'll put that there. And that connects our G into the tree now. Now looking at each of those, so I, we've got the 4, 6, we've got that 11 there, 8 and a 4. And off G we've got 5, 3, 5. So the smallest one then is that 3 that's connecting G to B. So we've got a 3 now. Now we're looking again at and including anything that we've added on. So off B we can have, and I should circle the B because we've now used the B. We've got 2, we've got 5, we've got 15, we've got the 11, the 4, the 5, the 12, and the 8, 4, 6 there as well. So overall that smallest one there was the 2. So we can add that on now. And then looking again, we've got the 15, we've got the 11, we've got 6, the 4, the 8, and we've got the 13, 12, 5, and that 4 there. Now we don't want to connect that I to G1 because G is already connected in already, so we don't need that. That would then create a cycle, so you're always looking for that there. We don't want that. So we're not going to use that one, but we will use the other 4. So we've now got that 4 there, and now we're looking, we just need to connect in the C and the E. So we can go the 9 or the 6, 15 or 11 to join on C. So that means we will use the 6 as the smallest one to join on C. And then looking at the E, we can go the 8, the 12, the 13 or the 12. So obviously the 8 is the smaller one. And we can join that in as well. So we've got the plus 6 and the plus 8. So we've got our highlighted ones 2, 3, 3, 1, 2, 8, 4, 6. So we can add them up, and that will tell us what our minimum amount is for that minimum spanning tree. So we've got 29 there as our answer. So I will do another video on a shortest path one and see what the difference is for that. But our minimum spanning tree, you're just wanting to be connected, so used for different types of scenarios.